Okay, for today's lesson, we're going to start off by learning how to sketch absolute value function. So what is an absolute value function? So basically we have modulus in the function. So there are a few steps to sketch modulus function. The first step is to identify the basic shape. We have two basic shapes. It depends on the coefficient of modulus x. If we have a greater than 0, we have something like v. When we have a negative, a less than 0, we have upside down v. Second step is to find the coordinate of starting point. So what is coordinate of starting point? The vertex. Next step, we have to find the x and y intercepts if we need to. So if we look at example 10, sketch the graph of the function, state domain and range for each of the function. So first we have to determine the basic shape. So we have positive modulus. So our graph should have V shape. After that, we need to find the coordinate of starting point. So the coordinate of starting point, we take all terms in the modulus. So for x minus 1, we let it as 0. So for x equals to 1, x equals to 1 over 4. So 1 over 4 is the x coordinate for the vertex. After that, outside the modulus, we don't have any number. So we can write it as plus 0. It means the y coordinate for the coordinate of starting point is 0. To sketch whatever that we have right now. So draw the x-axis. After that, draw the y-axis. x1 over 4. So 0. So we should have something like this for our function. So if we need to find the y-intercept, we just let x equals to 0. So y equals to modulus negative 1, which equals to 1. So this is 1. So for domain, we can see that our function has values from negative infinity up to infinity. So all real numbers. And for the range, the lowest our graph can go is when y equals to 0. And the graph moves upward up to infinity. So our range starts from 0 to infinity. Next, for B, we have y equals to negative modulus 1 minus 3x plus 2. First, we have to determine the basic shape. So since the modulus is negative, so we're going to have an upside down v. So for the coordinate of starting point, we let every term in the modulus 1 minus 3x equal to 0. So 1 equals to 3x, x equals to 1 over 3. So 1 over 3 is the x coordinate for coordinate of starting point. And after that, we have plus 2 outside the modulus. So plus 2 will be the y coordinate for the coordinate of starting point. So draw the x-axis. After that, draw the y-axis. Plot the coordinate of starting point. So 1 over 3 and 2. So this is the coordinate of starting point. For this example, we need to find the y-intercept because we want to know whether the graph passes through the origin or doesn't pass through the origin. So let x equals to 0. So y equals to negative 1 minus 0 plus 2. So we have minus 1 plus 2. So y coordinate equals to 1. So since the y-intercept is 1, it means our graph doesn't pass through the origin. So for domain, we can see that we have graph for all values of x. So the domain will be all real numbers. And for the range, the lowest the graph can go is negative infinity. And the highest the graph can go is 2. So the range will be negative infinity up to 2 square bracket at 2. Piecewise function is a function defined by multiple subfunctions applying to a certain interval. For example 11, we have to sketch the graph of the function, state domain and range for each of the functions. So we have two subfunctions in this function. And the first subfunction is for x less equal to 3. And for the second function is for x greater than 3. So first, sketch the x-axis. Then sketch the y-axis. Take note where the x equals to 3. So we're going to separate the two regions. The first region is for x less equals to 3. So for the second region is for x greater than 3. So for x less equals to 3, the function is a quadratic function. So since the coefficient of x squared is negative, we're going to have a maximum graph, a set graph. The maximum point should be 0, 0. Then you want to know where our graph ends. At x equals to 3, y equals to negative 3 squared, negative 9. So it means this the end point is 3, negative 9. So this is the left side of the graph, and for the right side of the graph, we have shaded circle at 3, negative 9. For the second subfunction, 2x. So the function 2x is a straight line. It is a linear graph. When x equals to 0, y equals to 0. So the graph passes through the origin. So this is a graph for y equals to 2x. But since we're only we're only sketching 2x when x greater than 3, it means we're going to just draw the upper half of the graph. So we have to know when x equals to 3, what is the endpoint? What is the y value when x equals to 3? So let x equals to 3, y will be 2 times 3, which equals to 6. So this is 6. Since x is greater than 3, x doesn't include 3. So for the straight line, we're going to have an empty circle at x equals to 3. Then we draw the straight line. So this is our graph. So for the domain, as we can see, we have graph for all values of x. So all real numbers. However, for the range, we can see that the lowest the graph can go is negative infinity up to 0. So from 0 to 6, we don't have any graph. We will only have graph starting after 6 onwards. So the range will be from negative infinity up to 0, inclusive, and the 6, round bracket at 6, because we have empty circle at 6, to infinity. Exponential and logarithmic function. For exponential function, the general form of an exponential function is fx equals to a power x plus k, where x is the element of real numbers and a is greater than 1. So from the general form, we can get the horizontal asymptote, which is y equals to k. To sketch an exponential graph, first we have to identify the basic shape. So there are 4 basic shapes. So if we have y equals to positive a, positive x, as x approaching negative infinity, our graph will approach the horizontal asymptote. And as x approaches positive infinity, the graph will increase without bound. When y equals to positive a, negative x,
As x approaching negative infinity, our graph will increase without bound, while as x approaching positive infinity, our graph will approach the horizontal asymptote. For y equals to negative a positive x, our graph as x approaching negative infinity, the graph will decrease without bound. As x approaching positive infinity, our graph will approach the horizontal asymptote. And lastly, when y equals to negative a negative x, as x approaching negative infinity, our graph will approach the horizontal asymptote, and as x approaching positive infinity, the graph will decrease without bound. After identifying the basic shape, we have to determine the horizontal asymptote. As we learned earlier, the horizontal asymptote can be obtained from the general form y equals to k. After that, find the x and y intercepts if we need to. Example 13, sketch the graph of the following functions. So a fx equal to 3 power 2x plus 1. So first we have to determine the basic shape. We have positive a, positive x. So ini bentuk graph kita. After that, we have to determine the horizontal asymptote. So kita akan ambil term yang bukan exponential. So the term that is not exponential is plus 1. So our horizontal asymptote is y equals to 1. So we can start draw the exponential function. Draw the x-axis. Draw the y-axis. Draw the horizontal asymptote. A dotted line for the horizontal asymptote. Then we sketch the graph. As x approaching negative infinity, our graph approaches the horizontal asymptote. And as x goes to infinity, positive infinity, our graph will keep on increasing up to infinity. So for the domain, even if the question doesn't ask for the domain, so we try to state the domain. So paling kiri graph ni boleh pergi negative infinity, and paling kanan graph ni boleh pergi positive infinity. Paling bawah graph ni boleh pergi 1, tapi dia tak akan sentuh 1. So all real numbers for the domain. And for the range, it approaches 1 but doesn't touch 1. So round bracket at 1. And it keeps on increasing up to infinity.
First, we need to find the horizontal asymptote. So the horizontal asymptote is y equals negative 1, which is the term that is not exponent. And then draw the y-axis and x-axis. And draw the horizontal asymptote. Y equals negative 1. And then since our value for x is negative and our value for y is also negative, so it's going to start from here until approaching asymptote. So for the domain, it's going to be all real numbers, negative infinity, infinity, and the range is negative infinity, negative 1, open bracket.
Next, for logarithmic function, it is of the form fx equals to log x minus k to the base a, where x is greater than k and a is greater than 0. So previously, we know that exponential function has horizontal asymptote. So for logarithmic function, we have vertical asymptote. So the vertical asymptote can be obtained from the expression inside the log. So x minus k we let equal to 0. So x equals to k. So this is the equation for the vertical asymptote. So to sketch logarithmic function, first we have to identify the basic shape. For y equals to positive log positive x, this is the shape for the graph. For y equals to positive log negative x, this is the shape of the graph. For y equals to negative log positive x, this is the shape of the graph. For y equals to negative log negative x, this is the graph. The next step is to find the vertical asymptote, and if we need to, we have to find the x and y intercepts.
Example 14, we have to sketch the graph of the following function. So first, we have to determine the basic shape. We have positive log, positive x. So the graph should look like this. Then we find the vertical asymptote. So the vertical asymptote, we take the expression inside the log, x minus 1, equate to 0, so x equals to 1. So this is the vertical asymptote. So we can start to draw the graph. We can start to sketch the graph. X-axis, y-axis. First, draw the vertical asymptote. At 1, we have a dotted line, x equals to 1. Then we can sketch the graph. So for domain, we can see that the graph starts after x equals to 1. So round bracket at 1, and we have x values up to infinity. And for the range, the lowest the graph can go is negative infinity, and the highest the graph can go is positive infinity. So all real numbers. For B, fx equals to positive ln minus x. So positive ln minus x. So this is the shape of the graph. So the vertical asymptote should be on the right of the graph. So vertical asymptote can be obtained from the expression in the log. So 3 minus x equal to 0, x equals to 3. So we can start to draw the graph. X-axis, y-axis. Draw the vertical asymptote at x equals to 3. So for this question, we need to find the y-intercept because we want to know whether the graph passes through the origin or doesn't pass through the origin. So we let x equals to 0. So when we get x equals to 0, y equals to ln 3. So the value for ln 3 is 1.0986, somewhere around here. So our graph doesn't pass through the origin. So it should look like this. Okay, so for the domain, we can see that we have graphs from negative infinity up to 3, but doesn't include 3. So from negative infinity up to 3. And for the range, the graph can go to negative infinity up to infinity. So all real numbers.
0.5 Trigonometric functions. At the end of the lesson, students should be able to find the domain and range of trigonometric functions, sketch the basic graph of trigonometric function such as sine ax plus b, cos ax plus b, and tangent ax plus b. For the sine function, it can be written as fx equal to sine ax plus b, where x subset or real numbers. The maximum value is 1 and the minimum value is 1. This can be seen from the graph. The maximum value here is 1 and the minimum value is negative 1. Therefore, the amplitude of the graph is 1 unit. If there is no condition, the domain for the sine function is negative infinity, infinity, or real numbers. For the range, it is always negative 1 until 1, because we could see from the minimum value here is negative 1 and the maximum value here is 1. So the range is negative 1, 1. Cosine functions. A cosine function can be written in the form of fx equal to cos ax plus b, where x subset all real numbers. The maximum value for cosine function is 1 and the minimum value is negative 1. This also can be seen from the graph. The maximum value here is 1 and the minimum value is negative 1. Hence, the amplitude of the graph is 1 unit. The domain for the cosine function is the same with sine function, which is negative infinity infinity, or all real numbers, unless there is condition. And for the range, it is -1 until 1. We refer the maximum and the minimum value. Next, we are going to learn how to sketch a tangent functions. A tangent function can be written in the form of fx equal to tan ax plus b, where x subset all real numbers. The graph has no maximum and no minimum value. The function is not defined at x equal to pi over 2, x equals to 3 pi over 2, and so on. The value here is also known as asymptote. The domain for the tangent function is all real numbers except the asymptotes. And the range, it is always negative infinity up until infinity. Example 14. Sketch the graph of the following trigonometric functions for 0 less than equal to x less than equal to 2 pi. Hence, state the domain and range for each graph. A, fx equals sine x minus pi. For this question, we have condition, which is x must be from 0 until 2 pi. So I list down several values of x that lies from 0 until 2 pi, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. In order to find the values of y, I'm going to let y equal to sine x minus pi. So for x equal to 0, I substitute into the function. So I have 0 minus pi. And then I substitute into the calculator. So I have y equals 0. So the value of y here is 0. I do the same thing for x equal to pi over 2. So y equals sine pi over 2 minus pi. So I have -1. Next, x equals pi. Y equals sine pi minus pi, which is 0. Next, x equal to 3 pi over 2. So y equals sine 3 pi over 2 minus pi, which is 1. And the last value of x, which is 2 pi. X equals 2 pi. Y equals sine 2 pi minus pi, which is 0. So I write down all the values of y that we already get and start to sketch the graph. So draw the y-axis, the x-axis, and put down the values of x, which is 0, pi over 2, pi, 3 pi over 2, and the last one is 2 pi. When x equals 0, our y is equal to 0. So it's going to be here, 0, 0. Next, x pi over 2, our y -1. -1 should be somewhere here, so -1. Next, for pi, y 0 here. And then for 3 pi over 2, 1. 1 here. Last one, 2 pi, y 0 here. Then just simply join the point. So this is the graph for y, this is the graph for fx equals to sine x minus pi. Next, we need to find the domain and range for the graph. So for the domain, we can see that our graph starts from x0 until x2 as the condition. So our domain is 0 until 2 pi, close bracket. And then for the range, our value of y starts from -1 and then it stops at 1. So range is -1, 1. Next, we're going to sketch the cosine function. For example, fx equal to cos x plus pi over 2. This is also valid for x from 0 until 2 pi. So, same as sine function, I already write down the values of x that lies from 0 until 2 pi, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. We just need to find the values of y by making fx equal to y. So, y equals cos x plus pi over 2. And then just substitute every single values of x to get the value of y. So, when x equal to 0, y equals cos 0 plus pi over 2, which is -1, which is 0. And then when x equals pi over 2, our y is cos pi over 2 plus pi over 2, which is -1. Then x pi y equals cos pi plus pi over 2, 0. X equals 3 pi over 2, y equals cos 3 pi over 2 plus pi over 2, 1. And the last one, x 2 pi, y equal to cos 2 pi plus pi over 2, which is 0. Write down all the values that we have here: 0, -1, 0, 1, and 0. And then prepare to sketch the graph. Draw the y-axis and also the x-axis. Write down all the values of x: 0, pi over 2, pi, 3, pi over 2, 2 pi. And then the values of y that we have is just 0, 1, and -1. So -1, 1. And then just plot the graph. When x is 0, y is 0. X pi over 2, -1. X pi, 0. 3 pi over 2, 1. And then 2 pi, 0. And then just join the points. So we have the cos graph. Next, find the domain and range. So for the domain, for this function, it starts from x0 until x to pi, close bracket. And then for the range, the lowest value for y is -1, and then the maximum value is 1. -1, 1, close bracket. For the tangent function, fx equal to tangent x plus pi. So we do the same thing. We find the values of y when x equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when x equals 0, we need to let fx equal to y first. Y equals tan x plus pi. So when x 0, y equals tan 0 plus pi, which is 0. Next, when x equals pi over 2, y equals tan pi over 2 plus pi, which will give us the value of math error. You'll get math error. Math error means infinity. Next, x equals pi, y equals tan pi plus pi, which is 0. X 3 pi over 2, y equals tan 3 pi over 2, plus pi, which is also math error, which means we have another asymptote when x equal to 3 pi over 2. So the value is infinity. And the last one, x equals 2 pi, y equals 10, 2 pi plus pi, which is 0. So write down all the values of y, 0, infinity, which is the asymptote, and then 0, another infinity, another asymptote, and then 0. Next, draw the y-axis, x-axis, write down all the values of x. Okay, and write down the values of y. So when x equals 0, y is 0. Here, when x pi over 2, y infinity, which means we have an asymptote here. And next, pi, when x pi, y 0, here. Sorry. Here. Next, 3 pi over 2, another asymptote. 3 pi over 2. And then 2 pi 0. Okay, so we know that when x equal to pi over 2, the value of y is approaching infinity. So it should be somewhere here. So just join the graph. We get like this. Next, the other one. When x 3 pi over 2, y approaching infinity. So from here, get down here, then get down. And then the last one, 2 pi 0, which is sketch the graph like this. So the domain for tangent function, for this example, it starts from x0 until x2 pi, 0 to pi, whereas the range, it starts from here. Here is negative infinity because the graph is going down there, so negative infinity, and then the maximum value is infinity. Next, we are going to look at how to find the domain and range of a function by using algebraic method. For the domain, we need to consider possible values of x that can be substituted so that fx is defined, positive values, negative values, or 0. For range, we need to determine the possible y values with respect to the values of x in the domain. There are 4 types of function that have domain restriction. The first one is for reciprocal function. Take the denominator and make it does not equal to 0. The second one is for the square root function. Take the value underneath the set and make it greater than or equal to 0. For the third function, logarithmic function, we know that log must be positive, so set the values here and make it greater than 0. And the last one is for the tangent function. We make x does not equal to pi over 2 plus n pi for n equals to 0, 1, 2, 3, and so on. Example 15. State the domain and range for each of the functions by using algebraic method. In order to use algebraic method, we have to bear in mind that only these 4 functions have restriction for the domain. Unless, other than that, the domain is going to be all real number or negative infinity until infinity. For the first one, for the first example, fx equal to 2x plus 5. This is a linear function. Linear function is not included in this 4, so x subset or real number. So the domain is all real number. Next, to find the range, we let y equal to fx. So y equal to 2x plus 5. And we rearrange until we have x as a subject. And then we look at here, and y is not included in this 4 function as well. It's not a reciprocal, it's not a square root, log, or tangent. So y is subset, can take all the values from negative infinity until infinity. So y subset all real number. So the range is also going to be all real number. Next, B, fx equal to 3 over x minus 1. This is a reciprocal function. So we know that for the reciprocal function, denominator cannot be equal to 0. So here, we take x minus 1 cannot be equal to 0. So x cannot be equal to 1. So the domain, df, the domain is all real number except 1. Next, for the range, we let fx, y equal to fx. So y equal to 3 over x minus 1. Rearrange until we have x as a subject. Over y plus 1. Y is also reciprocal, so y, denominator, cannot be equal to 0. So the range, Rf, is all real number except 0. Next, function logarithm. We know that for any logarithmic function, the values must be positive. So take 7 minus 3x and make it greater than 0. Rearrange until we have x as a subject. So x less than 7 over 3. So the domain is any number that is less than 7 over 3. So negative infinity until 7 over 3, open bracket. Next, for the range, let y equal to fx. So y equal to log 2 7 minus 3x. Rearrange until we have x as a subject. So 2 to the power of y, 7 minus 3x. So x equal to 7 minus 2 to the power of y over 3. So y here is not one of these functions. It's not reciprocal, it's not square root, log or tangent. So there is no restriction for y. So y can be any numbers from negative infinity until infinity. So the range is all real numbers. All real numbers.